For Ozbay's fluid mechanics, and we are going to do part C today. And most videos don't go in depth of how you do each calculation, but I am going to do that right now. So if you take fluid flux, you pull this over here. So we're going to start off with, we're going to call this part C. You do not have to, but I am just for the demonstration today. Take the geometry, right click and hit new design modeler. And we are going to go ahead and let this load up. Alright, and now we're going to go to sketching, hit the Z-axis, take the rectangle, and drag it out here. Just like project 1, you're going to kind of do the similar things here. You're going to take the horizontal, and for this project we're going to make it 1 meter. And for vertical, we're going to go and make it 0.1. Make sure you hit double ends, both the ends. Tap those ends before you drag it out to make sure it works. And then what we're going to do is we do concepts, surface and sketches, do box select, apply, and generate. And it is that easy. So after that you're done, you always want to go and update. So after you update it, you're going to double click and we're going into the mesh part. Alright, this is the part that actually gets most people, at least for me. So for this, we're going to right click, go to mesh, insert, and face mesh. You want to make sure this is the third option on here is unlocked. Clicked it, hit selection, hit apply, and generate. Alright, so if this is what it looks like with the multiple squares, you are doing a good job on this. So then you're going to go right click, insert, and we're going to do sizing. For this one, you want to hit this one, the second option for double sides. Hit apply, hit element, hit number of divisions. We're going to do 50 for this one. Capture curve. We're going to hit no. With this, we're going to hit hard. You want to do this so you make sure that your mesh is good. Just like the reason we did the sizing for the first one is we make sure that the height of it isn't too long, as Ozbay has said. You gotta make sure it's hard so it works properly. Number of divisions 50 because you need multiple divisions for this. And then you're gonna hit generate. So that's like this. And then again, we're gonna do this 2 more times because we want to make sure that this is working perfectly, and each of these sides here is gonna have different points. This one's gonna be reversed than this one. So same thing, apply element, number of divisions. This time we're doing 60 because we need these more sides to be more detailed to make this mesh properly flow. So for this, you gotta hit no. It is hard. Now this is what we're gonna do different. You see bias type? You're gonna change that to the first option up here. So 5, 3, 1, 1. And for vector 5, we're gonna hit 70. And then you're gonna hit generate. Sorry, that was my dog. Oh, hit the mesh. Good. And you're gonna update the mesh right here. And boom, this is what you want to look like. You see how it's more down here? That is what we need for this graph coming up, but this we need for the mesh. So then you're going to do insert, you're going to do sizing. You're going to hit this side right here. You're going to hit apply. Number of divisions, 60 again. So same thing as the other time, but this one's going to be reversed. So you're going to do bias type. And for this project to work smoothly, you do have to have it reversed. So you're going to have to double click it again, hit it again, and apply. You see how it says reverse bias 1 edge? You need that. So I'm going to explain it here. So You see how it's like this? Reverse option. For the way that the graph had the graphs properly, had the mesh for perfectly good, you need to have these the opposite. The mesh would not work properly later on if you do not have this opposite. So see how it's you just like there's bigger spacing more like on the top, but there's like a lot more crunch, a lot more of them. And then you go to edge 2. You see it's like top, and then it looks the same, but due to how it's in different sizes, it would be obviously see no reverse bias and reverse. So this is what you need right here. So I recommend for this to properly work, you generate it on the main mesh. Perfect. See, because you have to have them the opposite way. Normally it would be up. Normally it would be, if you didn't reverse it, it would be up, that part is up down here and this part's up here. But because we reverse it, it pushed it back here so they're even, making this perfectly good line. This is what you need to have the project to work. Now there's one thing we forgot to do, and we're going to do this right now. We're going to name them all. Just like last project, you have to name them all. So I'm going to call this upper wall. Actually, we're going to probably name it something else, honestly, because we're actually going to come back to this one. We're going to name this one first. We're going to call it inlet. We're going to call this one outlet. Then we're going to call the bottom one the plate. We're going to call the top one here far field. And then we are going to also name the middle of this. So we're going to take the middle one, right click here. We're going to go ahead and we are going to name the first one air dash flow. So when you look over here, you should have 5 named sections. Go back to workbench. You're going to want to make sure you update it because of the changes we just did. So this might take a second. Boom. And there we go. Setup, you want to open it, but it will ask you for change some stuff. We are going to change 2 things here. Once it loads, you're going to do double precision, and you're going to up it up to 2 solver precises. If you do not do this, the project would not work properly. And if we did this right, we should have a double arrows on the side of the green mesh we just did. So this might take a minute. I will come back and talk when it is back. You see here, okay, so it looks like we have done it correctly. You see there's the line on top, you got the double arrows and the green mesh. Okay, and the first thing we're gonna do, as you kind of normally do, you're gonna hit to models, velocity, and you're gonna call this Lamar. I don't really know how to pronounce half the stuff, but Lamar. I'm gonna call it Lamar. This is stack stuff you did in the last project. You need to make sure all these settings are privately right. So when we go ahead and make it run the calculations for the chart, that it will work perfectly as what we need. So then we're gonna go ahead and we're gonna go to material, fluids, air, double click air. So in the actual assignment here, I'm gonna try, I don't know if you guys see this, but I'll pull this up. In the actual assignment, we are called to go ahead and do length, 100 centimeters we did, that's 1 meter. Velocity is 2. density is 1.5, and air is 1.85 to the -5. This is what we're going to do right now. So we're going to go ahead and change this to 2. And we're going to hand this to change this to 8. Just to make sure that these are matching our assignment. Change and create. And you want to exit out of that. Then what we're going to do is we are going to go ahead and go to boundary conditions. We're going to double click this. And then we are going to go start with the inlet, and we're going to change the inlet to a symmetry. Actually, no, we're not. We are going to go ahead and, my bad, I'm just looking at my notes. We are actually, excuse me. We're going to hit inlet. Actually, this probably works better. You do out symmetry. Well, we're going to switch it back to. Move it down real quick. Alright, so change it back to velocity inlet. Remember that, and like the assignment said, we're gonna make it 2. So apply that. Then apply and exit. We're gonna go to plate. Double click. So you want to double click plate. Perfect. Stationary, no slip. Apply. You just want to double check, make sure everything is perfect. And then we are going to go to far field. And this is the one I meant to do symmetry to. So we're going to do symmetry and apply. Apply and close. All right. Now we're going to go to solutions, methods. Methods. And we're going to change this to simple. And then we're going to go to control, double click control. And you just want to double check. Pressure is 0.1, density is 1, body force is 1, and momentum is 0.7. Now we're going to go to this installation here. And you want to make sure it's standard. And for this, you want to make sure that velocity x is 2. Make sure this is put to the inlet. And make sure this is actually going to be 0. If you did all that, you're going to go ahead and insulate. Then we're going to do monitors, residuals, and we're going to add 2 zeros to each of these. So you want to add 2 zeros. They want to make, just to be a little bit more precise, and you're going to hit OK. And then after this, you are going to go ahead and you are going to run the calculation. Now, and I'll do this real quick about that, my dad called me, but like I was saying, most people do number of iterations, and personally for me, they do like 10,000. I think that's nuts. Personally, we're just going to do 500 because we do not want to take that much time, and honestly, we are not going to really use every single one of those data points. So you don't want to hit calculate. And then you're going to see this might take you about a few minutes. But shall wait for them. Well, I say a few minutes, but it's going pretty fast because we did not want to do it. Personally, the video that I saw of the users project said 10,000. I thought that was kind of nuts. So the calculation is complete. Perfect. That is what we go ahead and want right there. And we do not want to do this, so we're gonna go to plot, XY plot. And we are gonna do 2 different plots, and you would use these 2 plots for your assignment. So the first one you're going to do, you're going to go here, the pressure, and you're going to make it wall flexes. You'll keep this kind of the same for both. You do wall shear stress for this one. You'll go ahead and you'll make sure that it's plate, order points, and then you're going to do save and plot. This way you want. This way you want the zeros. One is like that far down, all the way up to that value right there of E. 8 e to -2. Perfect. And for this one, you do write a file, and you do write. And you save it to here, so pick your definition, name it, and you will go ahead and you need to import this. So I'll show you how I did mine later. And then for the next one, you're going to keep like this. You're going to change this to skin friction. Yep. And then you're going to go ahead and keep a play, keep everything there, and save and plot. And you see how this one is a little different. That is what you're going to have for this. And now we get to more of the fun parts. So you got both your graphs here. And what you want to do for this is once you go on here to you're going to have something like this. So this is what's having me saved. You double click it. Normally you want to hit notepad, and I'm just going to show you the first one. So this is my skin friction one, and this is what it looks like. You want to copy it just like this, and what you're going to do is you're going to go to Excel. So I'm going to show you. This is the Excel project I did from my class. So you got Y value, you got shear stress, wall shear stress, you got the second Y value I did, because I just did copy graphs. You got skin friction coefficient, you got Rx, you got wall shear theoretical, and you got skin friction theoretical. Now what you do is you're gonna obviously, so your skin friction ideas, you're gonna post it here. So this is mine, and the wall stress, this is it. So these are the 4 problems I got. For the project here, it says plot the wall shear stress and the skin friction coefficient. We did that. And for that, and we did that because when we did these graphs, it kind of looks the same, but let's see if we can find. It kind of looks crazy right now, but this is the stuff we wanted for our graph. You had to go ahead and make those 2 different ones. The graph shows perfectly what we need. Position-wise, to use these calculations. We did everything properly. And I'm going back to Excel. And you see the Excel. The values you need to do for this, because it says right here that you need to have, along the flat plate of flux, compare it to the theoretical ones. You're called to compare it. And so for this, you need to calculate a few things. You need to cut R, Rex, capital R, Rex. You need to calculate the wall shear theoretical and skin friction theoretical. Now, I'm going to show you the formula I did for this one, since you will see all the formulas in here. There's the formula for this one is not really shown right here, but it's kind of, you gotta calculate REX. And normally the formula for that is going to be used like your density, all that. I don't have it right here properly shown, but this is what I did. But here I did the 1.2 and then 2, and then I did this value right here. And as we know from that, your density is 1.2, your velocity is 2, and your viscosity. So it is your density times velocity times your meters divided by the viscosity of the air. So velocity, density, meters divided by velocity. And that is your formula right there. I don't have it like properly shown, but that is exactly what you need. Okay, so we're gonna go back and hit this. Okay, no? Okay. And then you got your 2 theoreticals. So for wall shear stress, you're gonna go back here and you're gonna use the formula RW, which is 0.332, u to the 1/2, density to the 1/2, other u to the 3 to the second, and then x to the 1/2. And for this is what we got here. So we have 0.32 times 1000, which is your normal density like number, times 1.2 to the power of 1/2, times your viscosity times 1/2, times 2 to the 1.5, which is your velocity, and this is your normal density, this is your density, divided by your y value to the power of 1/2, and this is what you get for that. For skin friction, this one is also going to be given. This is the local skin friction, and it's 0.664 divided by the square root of your Rx value, and this is what it kind of looks like right now. 0.64 divided by the square root of e to 3 to the power of 10 to 3. And lastly, this is what your graphs look like. To do this, you're going to click these, your y value, your wash shear stress, and the vertical. For this one, insert recommended charts. Sometimes it does it. You gotta double check it sometimes. Okay, that was just being weird, but you got a line. Okay, there you go. Sorry about that, it just took a while. Then you hit this, and you hit create. And this is what you want to look like. I recommend changing the chart title to what I named it, and it's wall shear stress versus vertical. And then for finally, you want to do y value, wall value, skin friction coefficient, and the vertical one. And same thing, insert, not that, there. Recommended charts, line, and only mine is not working right now properly, but if you hit those values, it should pop another chart just like this one here. And you name it the skin friction coefficient versus vertical, and that is what you need to have done for the project. So if you do that, you are perfectly good to go.